We're going to talk about polynomials now and just introduce a little bit of terminology for polynomials. So in case you forget, a polynomial is a function. Oftentimes we'll write them as like p of x or q of x. In this case, p of x equals, and this looks a little bit daunting, but basically what it's saying is a sum of x terms whose powers are non-negative integers. So for example, like on the far right, we might have like an x to the 0, an x to the 1, all the way up to some finite n, which also should be a non-negative integer. And coefficients that are all real numbers. So the coefficients are your a's here with the subscripts that just go along with the powers of x. They can be 0, so we don't need every single term to show up in that sequence. Yeah, they can be any real number. So a lot of times when they're 0, we just don't write them. Yeah, so that's your general definition of a polynomial. I've just got some examples down below. You might have noticed they're not actually all polynomials. So for example, the first one, if I wanted to rewrite it in that notation above, I usually lead with the highest power. So I could just actually rewrite this as 11x to the 10, and then minus 2x to the 4, and plus 7. And so just to match this notation here, basically what we've got is that's your n there. That's the highest power of x that shows up. I mean, you could hypothetically say that there are higher powers and they all just have 0 coefficients, but why would you? So yeah, so we have that n equals 10 on that one. And then you would see that like the coefficient a9, since there's no x to the 9, that coefficient would be 0. A8 would be 0. The coefficient for 7 would be 0, all the way down to 4, where we actually have a numeric coefficient of -2. So the next one, b, what we actually have here is, if you remember that root x, we could actually write that as a power. And so what we would get for this one is 5 plus x. And if you recall, that's a power of a half. Now that is not in the notation above, because that half specifically is not an integer. I mean, it's not a non-negative integer, but it's in fact not an integer at all. We could say, if you like, it's not a natural number. So this one, in fact, is not a polynomial. And for the last one, maybe it doesn't look like a polynomial, but you know that we can simplify things like this. For this one, we might do FOIL to simplify. So my first 3x times 2x will be 6x squared. My outsides, 3x times 5 times -5 will be -15x. My insides, 1 times 2x is 2x. And then my lasts, 1 times -5 will be -5. Just jot the little note there in case you miss where I got those from. And then just clean up that middle term, 6x squared minus 13x, and then minus 5. So that definitely is in the notation above. So this one is in fact a polynomial. And of course, as is the first one. So typically where you divide by x's or something to do with x, or you have like other weird things like trig going on, those will not be polynomial functions. We need the x's to be specifically the base of the power and an integer numeric power. Another definition that I might as well throw in while I'm here is two things. We have the lead coefficient of a polynomial, and that will be the first non-zero coefficient of, and specifically when it's written in that descending order, of p of x equals an x to the n plus, and then all the way down to a1 x to the 1, a 0. So if we go back through these, the two polynomials that we've got and look for the lead coefficient, so maybe if I label those in green. So in the first one, the highest power that's showing up is that 10. And so 11 is the coefficient that goes with it. So that would be our lead coefficient. I mean, hypothetically, we could have a 0x to the 11 or a 0x to the 12, but we don't want the zeros. And then similarly, in the polynomial r of x over here, it's going to be your 6. And one more definition that I can talk about is the degree of a polynomial is the highest power whose coefficient is non-zero. And so maybe I'll use this burgundy color to highlight these ones. So for the first one, that would be the 10. Right? Again, we could write it as some other higher powers, but they'd have 0 coefficients, and so we don't want those. And then, of course, for C, the degree is going to be 2. And we wouldn't really talk about a lead coefficient or a degree for B because it's not a polynomial. So I'll just go through maybe one more example here. And just kind of a weird one. Let's say that p of x equals, let's say, 4x squared minus 3x cubed plus 2x plus 4x cubed minus 5 minus x cubed. And then I ask, what is the degree? So at first glance, you might look at this and say, well, the highest power I see is 3. But you have to be really careful. You should always simplify. Because if we simplify, you'll notice that we've got 3 like terms in this expression, the negative 3x cubed, the 4x cubed, and the minus x cubed, and they actually all cancel. Right? They actually go to 0x cubed. So there's actually no x cubed in the simplified version of this. So if we were to simplify it and write it in that notation above, we would have 4x squared plus 2x minus 5. And so our lead term is the 4x squared. So our lead coefficient is 4, and our degree then is 2. So we don't want it to just be the highest power that you see. It's got to be the highest power in that simplified form. Otherwise, it's not a well-defined notion. And we just spent that whole chapter on functions. We like things to be well-defined. We like there to be one answer when someone asks you a question. So that should cover all the main terminology that we'll see with polynomials. And we'll do a little bit more with polynomials in this section and get to a lot more factoring.